We live at the bottom of a fluid. The atmosphere is a fluid. It goes up 30 miles or so, kind of doesn't have a sharp edge and kind of peters out at the top. But we're way down at the bottom of this very deep fluid. And fluids exert pressure on objects that are immersed in them. So this fluid is exerting pressure on us. If you look it up in the textbooks, how much pressure there is exerted by the atmosphere, say at sea level, it's about 15 pounds per square inch. That's what the books will tell you. Well, 15 pounds, it's not very much, you know. I laugh at 15 pounds. I can lift 15 pounds with one hand tied behind my back. But it's 15 pounds per square inch. If I stop and think about it, I got a lot of square inches. And if I have 15 pounds on that one, and then 15 pounds on that one, now I got 30 pounds, and then 45, and then 60, and I realize that if that's true, pretty soon I'm talking about hundreds of pounds of force on my chest. And I say, well, how can I even breathe if there are hundreds of pounds of force on my chest? I'm not all that strong. Well, let's look at it in a slightly different way. Let me take this can, for example. And the can is not quite 10 inches by 10 inches, which would be 100 square inches if it were. But let's imagine it is just a little bit wider than that so that the numbers are easy to work with. If that were 10 inches by 10 inches, then there would be 100 square inches on the surface of that can. And if the pressure is 15 pounds per square inch, then according to that, there's 1,500 pounds of force on the top of that can. Now this can is not made of battleship steel. This is the El Cheapo can. And you say to yourself, well, that's impossible. I mean, if you had 1,500 pounds on that can, it would squash it like a bug. But it doesn't squash. Well, let's use our little rules of behavior of fluids and think about it for a moment. If you took a postage stamp size, 1 square inch, postage stamp size little piece of the metal, then what we're saying is there's 15 pounds of force on that little 1 square inch. But if you go inside the can, underneath the little postage stamp piece of metal, there's also a pressure exerted perpendicular to the surface on the inside and upward. And so on this little postage stamp piece of metal, we have 15 pounds down from the top on the outside, but 15 pounds up on the inside, and that keeps those two forces kind of in balance, and the postage stamp kind of stays in one place. But the question naturally arises, what would happen if we took the air out of the can so it could no longer exert the force on the inside upward? Well, let's see what would happen. This little device can truly be called a little sucker. And it'll take the air out of the can for us. We'll just hook that up there like that. And then, when we turn it on, the air comes out of the inside, and all that's left is the force on the outside of the can. No! It crushes it like a bug, just like you'd think would happen if you had 1,500 pounds on that metal can.